Depends on that. All your manipulations will be on that loop. Yeah? And most likely they will tell you what they're trying to correct the power factor towards. Yeah? So how I just do it? The first thing I just draw the current strand. What I add here now. So right now, I add this. So my angle is 36.86. Right now, my quadruple power is 37.486 kilowatt. And I don't really care about the rest. Means I could put this 50. I don't really care about S. I don't need S. Yeah, I don't really need it. This is the old. Yeah, there's the old. But right now, I need the new. And they will tell you where you're trying to correct your power factor towards. Right? So in this question here, they say most likely they said 0.95. I don't know. Yeah, you're correct, and it says 0.95. So because I don't know, you need to calculate where your new Q is. Remember, I tell you, the Q is what does determine the power factor correction, your Q. Nothing else, the Q. So right now, your Q all is this, right? So I need to just draw any triangle. This the P not gonna change because the horizontal piece, right? Not gonna stay constant all the time. I need to get what my new angle will be. So my new angle is cos inverse of whatever power factor they want to correct it to, right? So in this case, it will be 0.95, would say. If that's the they want to correct the power factor to unity, which is 1, it would be cos inverse of 1, which is 0. If they say correct it to a power factor of 0.8, it will be cos inverse of 0.8. Luckily in this question, they say correct the power factor to 0.95. So to get what my new angle will be, I need to get, well, let's use the equation. So PF, yeah, let's get. So let's say cos inverse of 0.95 is 18.2 degrees. So right now, my new angle is 18.2 degrees, right? So because this angle changed, right, my Q new will also change. Yeah, remember I told you all this will change. This will kind of like it's shrinking. So it's like basically this happened. You have the triangle, and you have Q here. And as you begin to add a power factor correction, your Q value will start to decrease. And it will just, as you increase your power factor, going closer to 1, it will just keep on going closer and closer and closer to the horizontal, which is P. And if you say you want to correct the power factor to 1, then basically the angle will be 0, because cos inverse of 1 is 0, right? So basically your real part and your quadruple will be actually the same thing. They line along the same line. Okay, correct it to 1. You can try to calculate a cos inverse of 1 is 0. So your P and your Q will actually be on the same line. Everything will literally be on the same line. Yeah? But let's keep that in mind. So like calculate the Q new. So Q new, you have an angle, we have this here, we have Q. So the limit of trigs, opposite, yeah, the adjacent. So therefore tan theta is equal to opposite and adjacent. So tan 18.2 will equal to the opposite, which is the Q new, divided by the adjacent, which is 50K. So Q new will equal to 50K by tan 18.2. Yeah, I mean, that's kind of calculator. So 50, 1, 2, 3, tan 18.2. So you get 16.439 kilovolts. Yeah, so that's why I want to correct it to. Yeah, but right now I add this. Yeah, so that's what the fun gonna happen, right? So now we know the Q new. I can plug it in here. Is equal to 16.439 kilowatt. Yeah. So what happened in the question is, in order to correct the power factor to what you want it to be, you basically just going to add a capacitor in parallel with the load. That's literally what power factor ideally is. You just adding a capacitor in parallel with the load. And as you add that capacitor in parallel with the load, it does change the reactive power, which is the Q. Yeah, and if you can actually increase this straight up to where the circuit will have no reactive power at all, the power factor will basically 0. Well, 1 in this case, sorry. Because cos inverse of 1 will be 0, meaning that it have no reactive part. Yeah? So there's that and a capacitor. So the question will always state calculate the capacitor to get a power factor, whatever, whatever. Yeah? So that's to finish it off. So we know Q new is this. We know Q old is this. So we need to get what the change is. So the change will basically be the charge or the Q of the capacitor. So therefore Q or the capacitor will just equal to Q old minus the Q new. Okay, what the difference, right? So that would just be to this 1.486 minus 16.439 kVAR. And once you do that, you should end up with 21.2 kilovars, right? Yeah. So that is what our capacitor V charge or the Q for the capacitor will be. Yeah. At this point here, you just have to use a simple equation, right? So the equation of what you have to remember is that C. I'm gonna write it for you. I'm gonna show you the full thing. I'm just not give you the question. So the equation you're using is Q is equal to V squared on Z. Remember, Q is not charge. Q is power. It stands for reactive power. That is symbol for reactive power. So remember, we had some equations for power from C-sec P is equal to VI, P is equal to V squared on R, and P is equal to I squared R. Remember those stuff? Now, if you're dealing with AC and capacitors and stuff, this R will be Z because it's have impedance. I mean, it's have a real and an imaginary, right? And this, well, this here will stay the same, right? So this equation here is what you're going to use. So in this case, in this P here, the power that we want is the reactive. So you're just going to replace the P here with Q. Yeah, and this V here is your V load. Yeah. So if I write in the equation fully, this is V load, just so you all not to get confused. I V load. Yeah, and this Z as well. Z. Not gonna change. All right, so this Z here, now we just deriving it here. So it'll be V squared LD for load, and Z, the impedance for our capacitor, yeah, is 1 on 2 pi FC. Yeah, this here is with reference to the capacitor. Yeah? So this is basically the equation you can use. Q is equal to V squared load on Z, and the Z for the capacitor is 1 on 2 pi F, or omega C. Omega is just 2 pi F. Right? And this equation is based on transpose for C, because it's C, C is what you want. All right, so where can I do that? Let's see if I have any space. I will do it up here in the middle, because it's just a transpose. So I'm gonna see what how to transpose, so I'm gonna slap down the equation. So when you transpose it, you'll get C is equal to Q divided by 2 pi F V squared. When you transpose it. Yeah, it does transposing. So this is Q capacitor, obviously, right? And 2 pi F, I believe the question stated that F was 60. Let me go back and see. Yeah, 60. We're going to put it right here. 60 hertz. So that'll be F. Yeah, so we continue the question now. It's just to plug in the values and get the answer. So Q cap is 21.1 kilovars, 2 pi by 60. And V, remember V is load, the V load is 440 here, right? So when you plug that in a calculator, you will just end up with actually I should just plug in the calculator. So that'll be 21,100 divided by 2 multiplied by pi multiplied by 60 multiplied by 440 21 1 2 3. You can plug everything in correct. 0.127 farads. And that'll be the squared. I am so sorry. Let's try that over again. We got the square. 21100 2 pi by 60 by 440 squared. I don't know why that capacitor is so big. Right, that make more sense. Right? That make more sense. I don't know why that thing's so big. Because capacitor that big, it's real dangerous. So you end up with 2.89 by 10 to the minus 4 farads. Yeah, you can convert that to micro, but I'm not in the mood right now. So I think that would be like 289 microfarads if you convert it to micro. Maybe wrong, maybe correct. I'm not sure. Long time I do that. We moved out two spaces that way you get mine. Yeah, so you're correct. Yeah, okay, correct. Yeah, and that is the capacitor. Fit. Yeah, and that is the end of it. This question here, all it really is when you're doing it, so that's to break down this piece here. Let's zoom in. When you're doing the question. As I told you, if they gave you multiple stuff, what I want you to remember, they could give you multiple loads. Like if the question here, they could give you multiple of these loads. Here, they could give you multiple. What you have to remember is if it's log, the power factor, the angle positive, right? If they say lead, the angle negative. You calculate your Q and everything. Your Q, if your angle negative, your Q could be negative. But that makes sense because Q pointing down. Once you do that, you add up everything together, you get overall S. Once you get overall S, the overall P, and the overall Q, all the steps will be the same. And the same thing will be for the power factor correction. It will be the same exact steps. Nothing will change. All you have to remember is you have to work each power triangle separately, add it up together. Once you add it up together, you end up with one resultant power triangle, and all the steps will be the same. It's exactly the same. So don't get confused if you see like a question like here. You see how they give you two log leads, same thing, same steps. You need the power triangle for this one, power triangle for this one. Once you do that, you add up everything together, it's the same steps, nothing gonna change. Alright, so let me just go back to this. I know this is one. So you have to draw your whole power triangle with everything else in it. If you didn't calculate your Q, calculate it. Then you have to draw the new one, which is where you want, right? So you have to calculate the angle first, which in this case will be cos inverse, however, I want to correct it to. In this case, 0.95 will be 18.2. Once you get that, you need to calculate your new reactive power with just tricks. It'll be certain time it will be 10. Opposite, because you know you'll have A most of the time. Well, all the time. You should have A all the time. Alright? So it'll be 10, a little bit of tricks, they get Q. Once you get these two values, the capacitor, the Q of the capacitor will be the difference of these two. So you just subtract it like we did here. And once you subtract it, this here will be the Q of the capacitor. Right, then you use this equation here. Then you can just write it down. And you just transpose in this piece here for Q. Let's be Q is equal to V squared load on, well, 1 and 2 pi FC. You just transpose in this here for C, because C is where you want. And when you transpose this for C, you're going to put this equation on top here. And from there, just plug in your Q cap, which is this 2 pi F. F will give you any question, and this is V load. Your V load in the question, they will give you it right next to the load. Look at right here, 440. Yeah? And you just plug it in and you get away capacitor values.